discover my talent.
The environment is good.
Encouraged us children to be excellent.
Wamune.
Combo University, a private chartered university that offers world-class education at all levels, including certificates, diplomas, bachelor's and master's degrees. Our courses include computing and IT, law, journalism, nursing, business administration, education, fashion and design, and many more. Admissions for the August 2020 intake are still open. Will you join us?
Okay, buterevu nkwaniriza nnyo ku BBS Telefina ey'Obwakabaka bwa Buganda. Muzzukulu wa Mugema Katumba Gerard nze nkubuuzaako mu kaseera kano kennyini atugenda mu nsomera mu ddiiro lyo zuukusa abaana omuyizi muzuukuse akwate ekitabo ajje mu ddiiro atandika okuba nga atagenda mu kiraasi asoma. Senior 6 betugendako physics omusomesa yatuuse dda bwe tugenda okuba nga tutambula. Somera mu ddiiro lyo kutuusibwako bannaffe aba Green Hill Schools amasomero ag'omulembe gy'olina okuba nga otwala omwana abeere ng'afuna ate ebiseera eby'omu maaso ebirungi ddala. Ate ne bannaffe aba Maryland High School gasangibwa Entebbe nabo batuteekamu ensimbi batambula naffe musomera mu ddiiro lyo kwoteeka naffe aba BIC peeni ey'omulembe gy'olina okugulira omwana wo naawe gy'olina okuba ng'okozesa mu woofiisi emirimu gitambule bulungi nnyo ddala. N'Enkumba University egenda okuwa ekyo ky'oyagala obeere omuntu ow'omugaso era yayaanirwa ku katale ak'ensi yonna bwe tutambula awo wano musomera mu ddiiro lyo. N'olwekyo gwe omuzadde mu kaseera kano zuukusa omwana wo wa siniya ey'omukaaga physics gwe tugendako mu kaseera kano kennyini. Kale kankutwalewo omusomesa tugende mu kiraasi.
Thank you, moderator. Good morning, students. Good morning, parents. Good morning, Ugandans. Once again, I am here for us to proceed from where we stopped. I want to welcome you to yet this lesson. To the students that are watching the lesson and the following, I want to remind you and welcome you back to our continuation. We shall be continuing with our topic on waves. And as I usually do, I know you are not able to respond to the questions, but I want to pose a few questions. We looked at the terms that are very common in exam. Terms like define amplitude, define wavelength, define phase, define speed, define frequency, define velocity. You can also be asked to write down the wave equation. They could even go ahead to ask you to write the wave equation for a wave traveling from left to right or right to left. I want you to ask yourself at this particular time, pause and see whether you actually can define three of the mentioned terms. Pause and ask yourself whether you can define three of the mentioned terms. If you can, then we are at the right footing. I want you to look at that curve. I want us to remind ourselves about what we looked at the end, and then we shall proceed to capture a little more work. When you look at that curve that they are showing you, we derived the wave equation. We looked at the phase angle. I will simply pick the phase difference phi as 2 pi out of lambda times the displacement x. We looked at the equation for the wave moving from left to right as A, the sine of omega t minus phi. But if phi is equal to 2 pi out of lambda, we were able to come up with this equation as omega t minus 2 pi out of lambda x. We are already aware that our omega is actually equal to 2 pi f. And we are also aware that our f is 1 out of t. if I substitute in for omega here, my y gives us a sine 2 pi t, 2 pi, okay, 2 pi, yeah, 2 pi is omega, 2 pi ft minus 2 pi out of lambda x. If I factor out 2 pi, y becomes the sine of 2 pi factored out into ft minus 1 out of lambda x. And if I choose to substitute for frequency using this, my y will be a sine of 2 pi into, if I substitute for 1 out of, for f, it will be 1 out of t minus 1 out of lambda x. This equation is key. This one is key. This one is also key. We need to know all of them in those different states. But again, if I choose to substitute in at this stage for frequency, we have frequency from the speed and the wavelength. Frequency will be equal to speed over the wavelength. So at this stage, we can choose to substitute in frequency as v over lambda. Remember, I also told you that if v is f lambda, I also told you that we can still say that v is lambda out of period. And I told you this is actually very rarely used by most teachers because we know that f is 1 out of t. This is also true. So at this stage, I can choose to substitute for f as that, and I would still get a, the sine of 2 pi. Where I have f, I can put v out of lambda times t minus 1 out of lambda x. That means that if I picked out that, I could still have this as a valid expression out of lambda into vt minus x. These equations, starting from here to here to here to here, are all referring to the same expression, but could be used depending on the way the question is asked. We had looked at that expression, but we did not have enough time to expose it to those degrees of understanding. I want to urge my candidates following to take note of that. You can actually copy down that. I want also to emphasize that the value of k, sometimes we use k here. We use k here. If we use k as 2 pi out of lambda, then we can still write this as y being equal to a sine of 2 pi. 2 pi, if I use it at this stage, that means if I entered this there, I would have that. So if I use it at this stage, I will have 2 pi ft minus k x. If I'm bringing in the k, then this expression must be brought at this stage. That this term here, which we have called partly the coefficient of x on the phase difference, can be replaced by k, and would have that equation as sine 2 pi ft minus kx. In that case, our k would actually be equal to 2 pi out of lambda, as you notice, and that is the wave factor or the wave number. I expect that if you are capturing anything, you have already captured this. So I will remove this part as you slowly capture the other part, and we continue to proceed with our lesson. From that point, we can go back and say generally. We can say generally for a wave moving from left to right, the equation we use is the common equation. We have looked at all the various ways of writing this equation. I can now write it as the sine of omega t minus kx. We now know what k is. And for a wave moving from right to left, y will be the sine of omega t plus kx. When it is moving the normal way, or what is very common to most of the students in physics or the teachers, it has a minus here. When it is moving from right to the left, it reaches point P first, and we usually say that it vibrates and arrives at P before point O, and therefore it would lead the one at O by that phase difference. That's why we use the positive. After generating these equations, I also want to emphasize, before we look at one or two examples, the other time we looked at just one example, I want to add on one unique example among those that I asked you to try out, and then we shall proceed to the next part. I want to emphasize that when you are given a question on waves, the equation can actually be brought and written as this sign, and would say kx minus omega t. The equation can be written like this. This is none compared to none of these two. But I want to inform my candidates watching that if the wave is written in this format, say they give you an equation, I will request the producer to go to questions. The second question, it should be on question number 2. The equation is given as 2 the sine of 2 pi into 0.25x minus 100t. You can move further down. The producer should move further down to questions. Where are their questions? Where are their questions? The question number 2. Yes, that very one. My dear students, you are seeing that question. That question, if you compare it with the question immediately below, that number 3, if you compare it with number 3, you will notice that this one brings the x, the term in the x first. Yet we are saying the general equation must be written like this, with the omega t before the kx. Now, if you are given a number like this, my dear candidates, you simply need to express the general wave equation in that format. You simply need to express the general wave equation in the format I'm showing you here. And the work here actually requires you to compare. Much as the question at hand is asking us to calculate the wavelength and the speed, I am going to go a little beyond and extract frequency, extract period, and the rest. If we look at this question, first of all, we notice that by comparing the two, that the 2 is in the position of A. The other important thing you should not leave behind is that they will always mention the unit they are considering in that equation. For example, here they are telling you that y and time are in centimeters and seconds respectively, as you can see. That implies that our amplitude, if it was required, is supposed to be written as 2 centimeters. But if we are going to use it further, which may not be the case, then we consider it converted to SI units. They want us to find the wavelength. And we are aware that if I pulled out this factor and I multiply it by this 2 pi times a quarter, this 2 pi times 1 out of 4, 1 out of 4 is equivalent to 0.25, is exactly equivalent to the k in this case, but the k is equal to 2 pi out of lambda if we remember what I talked about just before I rubbed off. Now, if the k is equal to this, it implies that at this stage, our pi out of 2 is actually equal to 2 pi out of lambda. And therefore, if pi is cancelled, then we can get our lambda here as 1 centimeter. Our lambda can be obtained as 1 centimeter, which you can convert to meters. This is our wavelength. But they are asking us to determine the speed as well. They are asking us to determine the speed as well. Now, if we are asked to determine the speed, it implies that as we determine the speed, we will be able to get, as we determine the speed, we know that speed is given by f lambda. So we need to find the frequency. We need to find the frequency. How do we find the frequency? We will go to the other part that has pi, that has time. If we look at this part and we compare it with this part, and we know that from the expression of omega, which is equivalent to 2 pi f, or omega t is equal to 2 pi ft, the t cancels out, implying that our omega is 2 pi f. But we are aware that our omega is 2 pi out of the period. Our omega is 2 pi out of the period. So if we have omega t is equal to 2 pi f, it implies that this 100t is omega t, and therefore, if our interest is to find frequency, we will simply say that 100 is equal to 2 pi f. Now, this 100 must have the 2 pi picked there. So we will have 2 pi times 100 being equal to 2 pi f. And of course, the 2 pi will cancel, and you'll get your frequency as 100 Hz. After getting the frequency as 100 Hz, then we can go ahead to find the speed here as 100 times the wavelength, which is 1 out of 100, and which would give you the speed as 1 meter per second, if the equation is indicated as we have captured there. We can look at question 3 before we leave the rest of the work for us to compare with the answers. Those who worked through those numbers can now confirm whether you actually got them right. Yes, we started by looking at this to find the wavelength. We got that. Now we can proceed and look at question 3. I think you have taken note of this. From left to right, the equation has a minus. From right to left, the equation has a plus. It's the same expression, but expressed with a change in sign. And that is very important, as we shall shortly see actually when we go to the principle of superposition. Equation 3, or question 3, says y is equivalent to a, I will use capital A, much as here we are using small a. Okay, let me say a. The sine of 100 pi minus pi x out of 15. The sine of 100 pi minus pi x out of 15. There should be a t there. I will request the students to add a t here. On your question, ensure you add a t there. One, they are telling us to find the wavelength. Two, they are asking us to find the frequency. And three, they are asking us to find the period. Find the wavelength, the frequency, and the period. By comparison, I said, if we compare this with the general wave equation, where we are saying it is a, the sine of, I can say 2 pi ft, 2 pi f is for omega, minus 2 pi out of lambda x. If we compare it directly there, then if we want wavelength, we shall look at the coefficient of x. That pi out of 15 will be compared with the 2 pi out of lambda. And if this pi cancels out, and our intention is to get lambda, our lambda will be equal to 30. But what are they saying? Here we shall assume that they are actually saying that the wave is in meters. Here I did not complete the whole question, but assuming that we are in meters, then the wavelength can be looked at as 30 meters. To find the frequency, we compare this part with that part. Ideally, this is a number that every candidate should be able to pass, and it is a prominent question, as you may be aware. To find the frequency, we look at 2 pi f. 2 pi f is the coefficient of t and should be compared with the coefficient of t in the question, which is 100 pi. Because the t cancels, the pi will cancel, and the frequency will be 100 divided by 2, which will give us 50 hertz. And then they are asking us to find the period. Of course, period is related to frequency by an expression, which I think the candidates are now well aware of, that the period f, t is 1 out of f, and therefore it will simply be 1 out of 50, and the units should be SI units of time. They should be seconds. Dear candidates, I will, as I did last time, request that you try out numbers 4 and 5. 4 and 5. Number 6, we are coming for it shortly after introducing our next concept. Our next concept, I was still catching up with unfinished work of our last lesson. Today I want us to focus on a new principle that will allow us be able to generate an equation for a stationary wave. We shall call it the principle of superposition. The principle of superposition. You can put a question that says, state the principle of superposition. State the principle of superposition. I want you to keep focused on that question 6. We are shortly going to do it after stating this principle and doing a small introduction. State the principle of superposition. The principle of superposition, my dear candidates, states that the resultant displacement at any point is the algebraic sum of the separate displacements due to the two waves. It states that the resultant displacement at any point is the algebraic sum of the separate displacements due to the two waves. The resultant displacement at any point is the sum of the separate displacements of the two waves, is the sum. Some people may say the algebraic sum of the separate displacements of the two waves. Now, when we look at the principle of superposition, again, we will be reminded, just for the purposes of reminding ourselves, when we are dealing with waves, we call this a crest, and we call this a trough. That is for a progressive wave. We are saying when two crests join, okay, this would be like interference. That if I have a wave that is moving in that format, let me just consider that, and I add it with another wave moving with that, the resulting wave is expected to have a greater amplitude than either of the two. So the amplitude increases. But if I have an interference, that would be constructive interference. If I have a wave moving like that, and I add it with another wave, this is moving like that, but I add it with another wave moving like that, and moreover, in the opposite direction, the resultant wave would be a flat one. This is destructive interference. Now, when we look at the principle of superposition, it actually lands us to what we are going to call stationary waves. Stationary waves can also be looked at as standing waves. And they have characteristics. The characteristics will actually help us to eventually generate an expression, but it is a common question they can ask you to state the characteristics of stationary waves. One of them is that they have the same amplitude. I'm not going to repeat these ones here. They have the same amplitude. They have the same frequency. That means that we can also say they have the same wavelength and they travel in opposite directions. So what is a stationary wave in brief? We can say a stationary wave is a progressive wave that is formed. A stationary wave is a wave that is formed when two waves are traveling in opposite direction towards each other, but with the same amplitude, same wavelength, same frequency, and same speed. Then we obtain what we call a standing wave. And we have said that when two crests join, then we have an increased amplitude, and when a crest joins with a trough, we actually have a zero amplitude. If a crest joins with a trough, if this crest is pushed back here, what we obtain here will be similar to this. And we shall define these points. we shall define points like nodes and antinodes. So I have stated the principle of superposition. I have answered what a stationary wave is, but in the spirit of capturing, I need to write the sentence here. We stated the principle of superposition, and we are saying that the stationary wave actually is produced from the principle of superposition. That if two progressive waves join, they are with the same amplitude, same frequency, same speed, and traveling in opposite directions, then we obtain a stationary wave. We can say that this is a wave obtained when two progressive waves traveling to progressive waves of the same amplitude, frequency, and the speed traveling in opposite directions. It is a wave obtained when two progressive waves of the same amplitude, frequency, and speed are traveling in opposite directions. When they meet, we obtain what we are calling a progressive wave. We obtain what we are calling a progressive wave. Now, the progressive wave is given by an expression. And if I may put a simple sketch here, if one wave is this one, assuming it stops there, if we get another wave, I would draw it coming from there so that I don't actually break the rules of the definition, but I could have drawn it from this side. But a student who is watching may say, but he's saying coming from opposite direction. Assuming this is going there and this is coming here, when they meet, what they form is a stationary wave. A stationary wave is a wave that is static. Stationary means static or not moving. Now it is characterized by these points. The points where the two waves meet will be referred to as nodes. These are nodes. We normally denote them with letter N. And the maximum or the middle points here, which we will choose to put at that stage, or we can put them here, are called antinodes. I will define these two important terms here immediately. What are nodes? As you notice from here, nodes can be defined as points of zero displacement. These are points on the wave of zero displacement. In other words, the displacement there is zero, and antinodes are points of maximum displacement of a wave. I will move straight to the wave equation. We have said there are two waves. This one, which is starting from zero, is compared to a sine curve. If I called it 1, I would write it as A, the sine of omega t minus kx. It is moving from left to right, as I said. If we compare this one, it is moving from right to left, and we said we simply need to negate the sign in the previous one. I am attempting now to answer question 6, part 3, if you can see it. We already know how to define amplitude. We already have the capacity to state at least 2 characteristics of a stationary wave, but we can state more than 2. And they are saying a progressive wave of this equation is refracted at a barrier. If it is refracted, the refracted wave will move in the opposite direction, if you know the concept of refraction. If this one hits here, it is refracted going back. And what results is what we are calling a stationary wave. And they are saying, can we show that the resultant wave is stationary? I have those 2 expressions. Actually, to get the resultant wave now takes us into the mathematics of trigonometry. And I will try to be a little faster here because I didn't want us to stop here. So the resultant, which we all know, we have said when the 2 meet, and that means when they meet, they join. When they join, we add them up. And if we add them up, we have the resultant wave as A, the sine of omega t minus kx, plus A, the sine of omega t plus kx. Now, this is what is supposed to give us a stationary wave. For purposes of making sure that my students understand, I will factor out the A. Let me do it like this. I will let omega t minus kx be A, and omega t plus kx, call it B. So my y will become a new expression which I can write as A into the sine of A plus the sine of B. I am not going to go deep into the mathematics, but if I have 2 sines, A minus B, maybe A plus B, yes, and A minus B, as you notice, this is like A minus, A plus. I can compare them with these ones. If we open brackets, just an expansion of this, since I'm teaching physics students, whom I am assuming are mathematics students, I'll go straight away. When I expand this one, it will be the same as expanding this. So since I don't have enough time to go into the details, I will simply show you that if I have sine into A minus B, for those who do not know, it is expanded to be A sine A cos B. If it's a minus, you maintain the minus, and you begin with, you interchange cos A sine B. If I have sine into A plus B, I will have sine A cos B, but this stays as a plus into cos A sine B. I want to bring to your attention that this is the same as the minus. If I let the omega t be A and kx be B, I'm talking about this expression. So whatever I'm going through here, eventually I will let it be applied on this general expression. If I add them up, if I choose to add these 2, it's like I'm adding this term and this term, with an exception of my A, which I'll have pulled out. So it implies that if I add them up here, I have sine into A minus B plus sine into A plus B on the left-hand side. But here I don't know whether you are all able to see that this term is going to become 0, this one, if I am adding. This is a negative, and it is cosine. It's like minus 1 plus 1. So I'll get this one adding up. It's also the same. It's like AB plus AB. So it becomes twice sine of A cos of B. And that implies that if I apply it here, I'll have my A into sine. If I opened it up, it will be sine of omega t cos of kx minus sine of omega t cos of omega t sine of kx plus the repeat of this, which is sine of omega t cos of kx. I'll just put it here, plus cos of omega t sine of kx. So this one will cancel out, and I'll stay with these two, implying that our y, which we are looking for, will be a into this plus this, which is 2 sine omega t cos kx. So generally, y is 2a sine omega t cos kx is the stationary wave equation, And if we recall, I want us to recall that at the start of this topic, we saw that y was equal to a sine omega t as a general equation. So if I consider that as correct, then I would look at the whole of this 2a cos x, that if this y is meant to look like this, then assuming that I may be called this small a, then I will have my y as 2a cos kx times sine of omega t, implying that this component I am calling small a now for my case is the same as 2a cos of kx. But remember, our k is what? 2 pi out of lambda. So it means that our amplitude, the whole of this is actually our amplitude. Because I have used capital A, I'm forced to use this. It means that 2a cos of kx is actually our amplitude in that case. And therefore, that amplitude is 2a cos of kx. And we have said that since the k is 2 pi out of lambda, we are saying that a is 2a cos of 2 pi out of lambda x. But ideally, this is the equation for a stationary wave. I have already emphasized that with a stationary wave, we have points that we call nodes and antinodes, and we can emphasize these points from there. That it follows that at amplitude is the maximum and equal to 2a. In this case, if we want to find the amplitude, this expression, the amplitude in our general expression is a. So in this expression, our amplitude, which we know as small a, which is the whole of this, a is going to be maximum when we say it is 2a times 1. And it will be times 1 if this component is equal to 1. If the cos of 2 pi out of lambda x is equal to 1. So if the cos of that is equal to 1, we are interested in finding what value of x will make this 0. What value of x will make this? Because the cos of 0 is the one that gives us 1. So the value of x that makes that give us 1, give us a, actually, it is a, is supposed to be either 0, because when x is 0 here, then it implies that the cos of that term is 0. When x is 0, we have that. When x is 0, when x is lambda out of 2, etc., it implies that we shall always have the cos of 2 pi out of lambda x as 0, as 1. And therefore, in that case, we shall always have amplitude as 2a there. And when it is 2a, it means it is giving us a point that we have referred to as an antnode. It is giving us a maximum point here, which we have called point A. And when we look at values that make it 1, when we look at values that make it, we are saying that it follows that the amplitude is maximum and equal to 2A when those points are there. And these points are points we have called antinodes. And by looking at that, if we are to sketch the wave pattern, then we relate it with the distance. If I look at this, I'll have this moving up to there, and this moving up to there. If I compare this length here with this length on a mile curve, we shall discover that if this is lambda, then half of it is lambda half, then quarter of it would be a quarter, this one. If we look at this, this is assumed to be the amplitude point. So this is simply a quarter of lambda, and this is another quarter of lambda. But the points they are giving us here are amplitudes. Here, these points are amplitudes, and this will be a node. Now, when we look at that arrangement, a quarter plus a quarter will give us a half. That means if we are looking at this as a length, it will be a half of lambda. Then points that would give us 0 displacement, when we look at this expression again, for the amplitude to be 0, for the whole of this to give us 0, then we need to look at kx, or 2 pi out of lambda. So the values of x that will be responsible to give us 0 will be values that can give us, for example, the cos of, when we put in lambda as a quarter. If x is a quarter lambda, it implies that the cos of 2 pi out of lambda times a quarter times lambda out of 4 would give us the cos of pi out of 2. And this is the cos of 90 degrees. And the cos of 90 degrees is 0. So values of x like quarter lambda, 3/4 lambda, and 5/4 of lambda will give us an amplitude which is 0. And that will now give us the points we are calling nodes. It will give us the points that in our definition we called nodes. We can conclude and say that with a stationary wave, there is actually no flow of energy. If you remember, I've told you stationary means standing or static within the medium, but there is energy of motion between each vibrating segment, and that energy is not transferred across the points we have called nodes. A common question which I already gave you here is when they ask you to distinguish between a progressive wave and a stationary wave. There are several differences. Progressive, we said it is a wave that is in motion, and therefore it transfers energy from one point to another, and the stationary wave will not be able to transfer energy. Now, this brings me to what we can call fundamental frequency. If we had a string, as we come towards the end of our lesson, we will appreciate we started a little late than our normal time. So I hope we shall have a few minutes to at least deliberate on the first part. If the string is plucked in the middle, if I have a string here and it is fixed at 2 points, those of you who know how to play stringed instruments like a guitar, if you plucked it in the middle, pull it down or up, it would form that. Of course, if you pull it up, that is the real. This one will be an imaginary wave. Now, if we have looked at this physics, we say this is a wavelength, this is half the wavelength. If we look at that, this length will be equivalent to a half of the cycle. And we already know the wave equation, that V is equal to F lambda. The frequency that will be formed here, the frequency that will be formed will be given by V out of lambda. And if we look at the lambda here from L is equal to lambda half, it implies that the lambda will be equal to 2L. And therefore, the frequency, ideally, which now I'm going to denote as F naught, will be V out of 2L. And this frequency has a special name. It is the lowest possible frequency that we shall call the fundamental frequency. It is the fundamental frequency. The note, therefore, that string will produce is called the fundamental note, otherwise referred to as the first harmonic. And its expression will be given by this. As we wind up, this is the expression for the first harmonic. And as you proceed, you would be able to look at if it is pressed a little more, it would go to that phase, and you would need to compare this length in terms of wavelength and be able to come up with what we call the first overtone. I hope that we shall be able to progress from there in our next lesson, but importantly, they can ask you to define the fundamental frequency, and we have said it is the lowest possible frequency. And here you are also expected to look at factors that actually affect the frequency in stringed instruments. These factors, we will look at them, but they will come from the expression of velocity, where we look at tension and mass per unit length. I want to wish you a good weekend and wish you nice, silent Easter celebrations as you're aware. But I want to thank the President and the Ministry and ask you to continue sanitizing, stay at home. Let us fight this challenge together. I wish you a good day. God bless you.
Tweyanzege bwe tutyo tutambudde ne physics senior ey'omukaaga okuva ewa Master Kakulu Dennis King's College Buddo kyenkakasa nti omuyizi ofunyeemu nnyo ate naddala ku topic eno gy'abadde akusomesa. Tugenda kubanga ate tweyongerayo n'omusomesa omulala naye mutukkirize tubeere nga tusooka kuwumulamu katono nnyo. Twagala okwebaza bannaffe aba Maryland High School abo tutambula mu nsomera mu ddiiro lyo. Essomero eryo lisangibwa wali Entebbe lya One Level. Abasomesa arts ne sciences balina ebisuulo eby'abawala n'abalenzi, balina environment nnungi ddala esobozesa omuyizi okusoma obulungi, balina lab esobozesa omuyizi awa sciences okusoma obulungi nga buli kyasoma ate era akikola mu practicals. Balina ebyemizannyo babitunuulira nnyo, n'olwekyo omwana wo ng'omwagaza ebiseera ebirungi eby'omu maaso Maryland High School Entebbe eryo essomero gy'oba omutwala. Ate n'amasomero aga Green Hill Academy Schools nago weegali aga primary nago masomero malungi nnyo. Omwana omutandise n'omusingi omugumu ddala abeere ng'ate aba n'ebiseera eby'omu maaso ebirungi ddala. Bannaffe aba BIC nabo tutambula nabo, peeni ey'omulembe nnyo gy'olina oggulirwa abaana bo nga baddayo ku masomero. Mu kiseera kino tulindirira tulabe kiki ekinaabaawo oba 27 amasomero banaaba bagaggudde nga abakulu bwe baatusuubiza, naye wonna ne bagaggulira. Bw'oba ng'ozzaayo abaana ku masomero ngula peeni eya BIC, ate nawe owa ofiisi oba akozesa peeni ebiseera byonna ngula peeni eya BIC yatagenda kubanga ate ekuyiwayo. Bannaffe abankumba University nabo tutambula nabo, batambula naffe musomera mu ddiiro lyo. N'olwekyo gwanoonya ate owootwala omwana wo ku university, omutendera omulala gwa university mutwale ku Nkumba University, ajja kubanga afuna omusingi omulungi ddala. Tugenda kubanga tuwumulamu ate mu bwangu ddala tugenda kweyunga ku musomesa omulala tubeere nga tweyongereyo. Tovaawo, somera mu ddiiro lyo.
somera mu ddiiro lyo ng'ewagiddwa. Maryland High School erisangibwa Entebbe, ssomero lya bawala n'abalenzi. Tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisulo eby'omulembe, science laboratory ssaako ne computer lab wamu ne.
She gives you her number, but your pen didn't work and the bus is gone. Get a pen you can rely on. Big Crystal, the long-lasting pen with perfect ink flow.
Wamu ne.
Green Hill Academy has high standards of learning and the teachers are very good. They give you a sense of belonging.
Green Hill has helped me to discover my talent.
The environment is good.
Encouraged us children to be excellent.
Wamu ne.
Combo University, a private chartered university that offers world-class education at all levels, including certificates, diplomas, bachelor's and master's degrees. Our courses include computing and IT, law, journalism, nursing, business administration, education, fashion and design, and many more. Admissions for the August 2020 intake are still open. Will you join us?